All right, so now we're looking at the back side of 14.3 on probability. We were talking about complementary events before, and now we're going to switch gears and talk about what odds are. Now, odds are really based on the idea of complementary events, but before we start talking about it in those terms, so odds based on complementary events. In other words, you can really only discuss what the odds are if you have all the options known. So in other words, when we were talking on the front and we were talking about Lake Park winning the championship and not winning the championship, those were complementary because either they had to win or they did not win. There weren't any other options. Either they win or they don't win. So we need to have complementary events to find odds. Now when we talk about odds, you've probably heard things before, like the odds are 3 to 7. In other words, there's 3 options for them to win to 7 of them to lose. So if we want to know what are the odds that they win and we say it's 3 to 7, there's 3 options for them to win and 7 ways for them to lose. The idea being that it would be 30% likely that they win and 70% likely that they lose. So these are probabilities. So we think about this, really it's the probability of the win to the probability of the lose from the front side. So whenever we do these types of things, when we're talking about odds and probability, odds really are based on complementary events and the probability of those complementary events. So it's based on the complementary events and the probability of each event. Of each event. Okay? The odds are really a ratio, which this 3 to 7 is a ratio. The ratio of the probabilities. Of the 2 events. Now when we talk about the odds, there's actually 2 different types of odds. There are the odds in favor, and then there are the odds against that particular event happening. So the odds in favor of it happening, of A happening, is really a ratio of the probability that that event does happen to the probability that that event does not happen. So the probability that it does to the probability that it does not. So because we are talking about being in favor, the probability that it does happen comes first. Probability that it happens comes first because we want it to happen, odds in favor, to it not happening. Now if we're talking about the odds against means we don't want it. So again, it's going to be a ratio, and it's going to be the probability, because we're looking for the against, the not A comes first because we are against it. So what's the probability that it does not happen to the probability that it does happen? So when you read it with the odds, you're going to have to be very careful about what it says. So if it says probability in favor of it, then the probability that the odds in favor, then the probability that it happens should come first and not second. But if it says against, the probability that it shouldn't goes first, and the probability that it does goes second. All right, so let's actually read a problem and do an example. So in example 1, if the probability of getting an A on the test is 54, then what are the odds in favor? Well, before I can even do this, we have to think about what the 2 probabilities are. So the first probability that we're kind of talking about here is the probability of getting an A. So that's the probability of getting an A. Sorry, 2 T's, getting an A. Equals, and they said 54%. Well, whenever we do probability, it shouldn't be a percent. It really should be more of a decimal or a regular number. So we can't have percent, so we're going to change this to a decimal, move it over twice to be 0.54. So probability of getting an A is 0.54. So the complementary thing to getting an A would be not getting an A. So the probability to not get an A. Well, since these are complementary, I know the probability of not getting an A will be 1 minus 0.54, right? Because either you get it or you don't, so the remaining of this is the actual probability to not get it, and 1 minus 0.54 is 0.23. So now we have the 2 probabilities that we're working with. So we have the probability of getting an A and probability of not getting an A. Then we can go back to the odds and say, okay, they want to be in favor of getting an A. So the odds in favor of getting an A. So I want an A to not getting an A, right? So probability of wanting it to probability of not wanting it, because in favor means we want getting it first. So this would be 0.54 to 0.23. Now the issue with odds are we don't want them percents and we don't want them decimals. So what I would do with this is I would just move the decimal over twice to create non-decimal numbers. So now this is 54 to 23. And then the issue is you can't leave them in this way. You have to reduce them. I'm sorry, 1 minus 0.54 is not 0.23, is it? That's what you guys were probably noticing a while ago. So 1 minus 0.54 is actually 0.46. So I apologize. Let's get rid of that. That's 0.46, which means this one is 0.46, which means this is 54 to 46. Now the issue with this, again, what I was trying to say earlier is you have to treat this almost as if it's a fraction that you can reduce. So is there a number that divides into 54 and 46 evenly so that I can reduce these numbers? Well, 2 goes into both of them evenly, so 54 divided by 2 would be 27. 46 divided by 2 would be 23. So the odds in favor of getting the A is 27 to 23. Then they want to know what are the odds against getting an A. In other words, we're doing probability of not getting an A, right, to probability of actually getting the A. So probability of not getting the A we found to be 0.46. To probability of getting the A is 0.54. Then we need to convert that so that there are no decimals, so we move them both over twice to get rid of the decimal, and it would be 46 to 54. And again, if we can find a common number that goes into both of them, then we should simplify that, and it would be 23 to 27, the odds against. So the odds of getting an A are 27 to 23. The odds of not getting an A is 23 to 27. So I want you to try number 2 on your own. Oh, nope, we're going to do that one together. All right, so if the probability that a student in class will, if the probability that every student in this class will be in attendance tomorrow is 7 to 10, what are the odds in favor? So again, the probability that everyone is in attendance, the probability that not everyone attends. Those are the 2 probabilities that we're looking for. So probability that everyone attends is 7 out of 10. Probability that not everyone attends would be 1 minus 7/10, which would be 3/10. So these are the basis of everything that we're going to do from this point on. Okay, so the odds in favor mean we want it to happen, so probability of what we want to probability of not that is going to be, in this case, probability that we attend is 7 over 10, to the probability that we don't attend is 3 over 10. Well, notice the denominators are the same here, right? And we don't want fractions and we don't want decimals and odds. So in order to get rid of that, we can just say, oh, look, they both have a common denominator. They go away. So the odds are really 7 to 3 in favor of everyone being there. All right, whereas when we look at the odds against, right, it's the probability that not everyone attends to the probability that everyone attends. So we just reverse it, right? 3/10 to 7/10. And then again, no decimals, no fractions. We get rid of the common denominators. So it is 3 to 7 against. Okay? Number 3, if the odds of the Cubs making the World Series is 14-10. So they're kind of doing this one in reverse, right? They are giving you the odds. They're saying, look, we're starting out saying Cubs making the World Series is 14-10. Then, what are the odds against them winning the World Series? What is the probability? So we should really break this up. It says that making the World Series, so odds to make World Series is 14-10 or 14-1. So in other words, we want them to make it, and what we want comes first. So this is that they will make it, and this is that they won't make it. So those are complementary events. The odds that they make it, what we're saying comes first. So they will make it is 14. That they won't make it is 1. So now, if we want to know the odds against, we can just switch that, right? Because the against should come first, and that they will come second. But then when it takes it a step further and asks you to look at the probability that the Cubs make it, well, the 14 is the starting point, right? Probability is what you want out of the total options. Well, the opportunities we have to get what we want is 14. And the total options is both how many we have to get what we want and what we don't. So 14 plus 1. So the probability of Cubs making the World Series is 14 out of 15. All right. Number 4. I'm going to at very least start you out with it. So, what are the odds in favor of rolling the same number when rolling 2 die? So, we need to know the probability of rolling the same number and the probability of not rolling the same number. Well, remember, probability is really what you want out of the total, right? So we're going to have to figure out how many opportunities to get the same number when you roll it, when you roll 2 dice, out of how many options. Well, first of all, let's think about how many options there are when rolling 2 dice. 6 times 6 means there's 36 options when rolling the die twice. Now, how many of those times would I get the same number? So you should make a list over here of all the opportunities to get the same number, to get the top number here, figure out the next one, and then go ahead and do the odds. So you're going to finish this tonight on your own. Okay? Make sure you come in tomorrow with any questions.